So another one of these problems that we have to do, this one's got a little bit of different stuff to it. They often ask you to find um, one expected frequency to prove you know how to do it. So Persian female Persian cats is this box right here. So it's row total, which is 18, times column total, which is 31, divided by grand total, which is 42. So I'm going to go to my calculator. I'm going to do, I already forgot the number, 14 times 31 divided by 42. 18 times 31 divided by 42. 13.2857, blah, blah, blah. I really only need to do three significant figures, so it's 13.3. So then it says, a chi-squared is pride at 5%. Use the term whether preferences independent of cat gender. Use your graphic display calculator to find a p-value. All right, so now I got to bring my calculator up, and I got to do some work here. Now I have totals along the bottom, but I don't have totals along the end, and I don't have a grand total. So I got to figure some totals out before I can do anything. So I move this over here, and I bring my calculator back up. So I have to add 34 plus 13 plus 21 plus 24. I did not type that in right. 34 plus 13 plus 21 plus 24. So that's 92. 92. And then it's 23 plus 18 plus 23 plus 18. I actually figured the expected frequency out wrong, so I'll have to redo that. 82, because I can't actually do that without what I have right here. 82. And then I got 57 plus. Oh no, wait, I'm not thinking here. All right, that's all I've got. Okay, and then I need to do add those together and make sure I know the grand total. So let's make sure they're both the same. So 92 plus 82 is 174, and then 57 plus 31 plus 44 plus 42 is 174. So 174. So let's go back to part A and actually do it the right way. I thought that last column was a total, which doesn't make a whole lot of sense. But anyways, so it's row total, which is 82, times column total, which is 31, divided by grand total. So 82 times 31 divided by 174. 14.6 is actually our expected frequency. That's why I do videos live without doing it beforehand, so you can see mistakes get made, because they're going to get made. You're going to make mistakes. If I make mistakes, you're probably going to make mistakes. Maybe not. Maybe you're better than I am at this stuff, which is fine. Okay, so we're going to do this matrix. It's 2 by 4. All right, matrix A is the actual observed value. So 34, 13, 21, 24, 23, 18, 23, 18. So there's my observed frequencies. Then I'm going to go back to the matrix. I'm going to go to B. I'm going to hit enter. And I'm going to go 2 by 4. Okay, so now we got to do some work here. So 92 times 57 divided by 174. And then 92 times 31 divided by 174. 92 times 44 divided by 174. 92 times 42 divided by 174. 82 times 57 divided by 174. 82 times 31 divided by 174. 82 times 44 divided by 174. 82 times 42 divided by 174. Okay, so there's my expected frequencies. I'm going to drag and drop matrix B into there so I can look at it if I need to figure out what I did wrong. Stat, test up to letter C. Everything's in the same spot. So there's my values. All right, so now I can make my determinations. So matrix B, we'll put over there. matrix A, matrix A, the answers we'll put right there. So it says that my p-value is 0.345, all right, 0.346. So now I've got to write a conclusion. Now, it didn't have me write a null hypothesis. So what I'm going to do here is I'm going to write this down. I'm going to think about it. So 0.346 is greater than 0.05 to compare to the significance level. So we accept the null hypothesis, which means, all right, now null hypothesis is always independent. So which means, what are we comparing here? So type of family cast. So we're going to have example of family zone cast referred by breed and gender. So type of cat owned and gender is independent, which means type of cat owned and gender are independent. That's a weird thing to look at, but that's okay. So type of cat owned and gender are independent, meaning that you're not, if you own a Persian cat, you're not going to more than likely own a female one than a male one. It's kind of what we're talking about here. So a little bit tricky there. They didn't have you write the null hypothesis. That doesn't mean you can't write the null hypothesis when you're doing one of these things. So, be careful with this. If it doesn't make sense the way they're asking you to do it the way that it makes sense to you.